Welcome to your Google Software Engineering interview. We're prepared to offer you close to $200,000, but we need you to answer this one question, and it's not what you expect. We know you've been grinding your LeetCode, but we don't care. Instead, we're gonna ask a class design problem. We want you to design a simple key value store, something that lets us set, get, and delete keys efficiently. All right, before I start, let me clarify the scope. Is this an in-memory key value store like a Python dictionary? Or is it something persistent like Redis where we'd handle storage and concurrency? Good question. Let's start small. In memory only, no persistence. Just basic set, get, and delete. Got it. Should I assume keys and values can be of any type? Yeah, that's fine. Think general purpose, not strongly typed. Okay, so the naive approach would be to have a simple list of key value pairs. Each time I call get, I'd loop through the list until I find the key. And how efficient is that? That's O of N, not great. Every lookup would require a full scan of the list. It might be fine for tiny data sets, but it doesn't scale. Exactly. So how could you improve it? You can switch from using a list to a hash map. Internally, that means using a hash function to map each key to an index in an array. The get, set, and delete operations will all run with an O of 1 constant time. That's perfect, but how do you handle collisions? There are two main strategies here. First would be chaining and storing a list of key value pairs at each index. The second would be open addressing. This means to probe to find the next empty slot when a collision occurs. For simplicity's sake, I'd start with chaining since it's easier to implement and more flexible with dynamic sizing. Good, but what about extending the design later? Say we did want to handle persistence or expiration like Redis does. In that case, I'd abstract the layer into its own class. Later, we could plug in a file system or even an in-memory/disk hybrid. And for expiration, I could store timestamps along with the key value, and then run a cleanup thread or scheduler to remove expired keys periodically. Awesome. So what's your final design? At its core, we have a key value class which implements our get, set, and delete operations. Internally, we have a hash table implemented with an array of buckets. Each bucket stores a list of key value pairs. We have a list to handle collisions. We're using the chaining approach. Next, we have our optional extensions. TTLs, persistence, and concurrency control. Perfect. And what's the big data structure takeaway? The key insight is how a hash table turns O of N lookup to O of 1 lookup on average. This is because we use a hash function in an array for direct access. This problem is really a gateway to understanding how Python and Java really creates a dictionary under the hood. Awesome, you got the job. I'm making a video like this each and every day to help you improve your pattern recognition for software engineering interviews. If you found this video helpful, drop me a follow. I'll see you tomorrow.